Hello, so in the previous video I've shown you how to do the calculation for an elastic collision. So in this video I'm going to show you how to do the calculation for a perfectly inelastic collision. Now the thing unique about a perfectly inelastic collision is that after the collision, the two balls will be moving at the same speed, same velocity. So instead of V1 and V2, we have only V. The two balls are like stuck together and moving at the same speed, same velocity V. And that makes our calculation very easy because just by PCOM alone, just one equation, the outcome is completely solved already. Yeah, it's really that easy because there's only one unknown V, right? Unlike elastic collision where you got V1 and V2. So again, I've plotted the momentum against time graph. So these are the momentum of the two balls before the collision, and these are the momentum of the two balls after the collision. Of course, if you add these two numbers up, they give you the same number because the total momentum must be conserved. In fact, if we assume that the momentum changes linearly for the red ball from here, from 12 to 8, then the blue balls will have this line, and these two lines are mirror images of each other. They have the same steepness because whatever momentum lost by the red ball is gained by the blue ball. It has to be so that the total momentum remains as 10 kg/s throughout, before the collision and even during the collision. Here we have the velocity plotted against time. So these are the velocities of the two balls before the collision. After the collision, they have the same velocity, right? So I draw just one line here. Just from this graph alone, you know that this is not an elastic collision because the gap between these two lines is the relative speed of approach, but the relative speed of separation is 0. So they don't match, right? So it's not an elastic collision. If you assume the red ball's velocity to decrease linearly like that, and the blue ball's velocity to change linearly like this, then even from this graph alone, we can tell which one is the heavier ball. The red one must be the heavier ball. Remember, the balls are experiencing an action-reaction pair. They experience the same magnitude of force, so the larger mass will have a smaller acceleration. What about the total kinetic energy? So if this is the total kinetic energy before the collision, then during the collision, the total KE is going to decrease, and after the collision, the total KE will be less than before the collision. Unlike the elastic collision, where the KE is temporarily stored as other forms of energy but eventually returned as kinetic energy after the collision, for a perfectly inelastic collision, that's not so, yeah? The KE is converted into other forms of energy, maybe heat, maybe deformation or whatever, and is not returned as KE to you. That's why the total KE is less after the collision. Alright, that's all. Ta-ta!